For the differential equation, dy dx is sine x over y is 2 when x is 0. Estimate the value of y when x equals pi by 3, using h is pi by 12. Now, since pi by 3 is equal to 4 pi by 12, we are going to need 4 steps here. It's unlikely in a test or exam question you're ever going to be asked to do 4 steps of this, 1 or 2 at most, I would say. Check by solving the equation and computing y when x is pi by 3. Okay, so we can identify here that our x0, y0 is 0, 2. dy dx evaluated at 0, 2 is going to be sine of 0 divided by 2. Sine of 0 is 0, and so that is going to be 0. Therefore, delta y is going to be 0. And so we are going to move to the point pi by 12, 2. Because the gradient is 0, the y will not have changed. And then we want dy dx evaluated at pi by 12, 2, which is going to be sine of pi by 12 divided by 2. Calculating, that has given me 0.1294 and so on. And to get the delta y, we need to take that and multiply it by the step length, which is pi by 12. So we're just going to multiply that last answer by pi divided by 12, and that gives us 0.033 and so on, which takes us to our next point, going pi by 12 further on, is pi by 6, 2 pi by 12, and then we're going to have 2.0338 and so on. And then we just repeat the process. We're going to do dy dx now, evaluated at pi by 6, 2.0338 and so on. And let's see what that gives us. So we're going to have sine of pi by 6 divided by 2 plus that, and execute. So that's 0.245 and so on. And then our delta y is going to be that times pi by 12. So we'll multiply that one by pi divided by 12. And we get 0.0643 and so on. And that will take us to 3 pi by 12. So 3 pi by 12, that's going another pi by 12 across, which of course is pi by 4. And then we've got 2 plus this one here, So we just need to paste that one there. And then plus our last answer, and that's 2.098, and so on. Okay, so next step, dy dx at pi by 4, 2.098 is going to be. So it is going to be the sine of pi by 4 and divide that by this, and we get 0.337 and so on. Our delta y is going to be that multiplied by pi by 12. So let's multiply that by pi divided by 12, and we get 0.088, and so we want the 2.098, which was our last y. Let's just copy that and bring it down here. Let's just paste it in there, and we'll add our last answer to that, and we get 2.186. So that has taken us to pi by 3, 2.186. Let's call it 2.1865, 4 decimal places. So that's our 4 steps, and we've estimated the value of y when x is pi by 3. Okay, let's solve the differential equation to check this. So we get y dy is equal to the integral of sine x dx. So that's y squared on 2 equals, if we integrate sine we get negative cos, so let's call this c take away cos x, and so y squared would be equal to some constant which we'll call a take away 2 cos x. Now y is 2 when x is 0, so we get 4 is equal to a take away 2, because cos of 0 is 1, and therefore a is equal to 6. So I have y squared is equal to 6 take away 2 cos x. Now that would mean that y is equal to plus or minus the square root of, and I think looking at what we did before, we're going to be using the positive root. So we'll just have 6 take away 2 cos x, and let's see what happens when we do y of pi by 3. So that gives us the square root of 6 take away 2 cos pi by 3. Cos pi by 3 is a half, so this is actually the square root of 5. And the square root of 5 is approximately, I did have it on the screen there, 2.2361. And our value from before was 2.1865. So not too bad. Let's check what we've been doing with the calculator. So the activities were on spec, and I like to use the Euler's method. So where are we? Euler's method using the sequences. And we did a step length here, which was pi by 12. So let's put that in here, pi by 12. And our initial value of x was 0. And then our step is pi by 12. So we can probably copy that, paste it down here, and multiply that. The differential equation is sine x. I should use a fraction, shouldn't I? So sine x over y, like so, except we don't use x and y. The x is an a and the y is a b, like so. That's all good. And our initial value of y was 2. And let's get rid of the keyboard and let's generate that, see what happens. So after 4 steps, 2.1865, notice how it's more accurate in the window below when you click on it. And so that was a correct estimate.